So today we're going to be talking about the sun. And let's go over some properties. Yeah, this is going to be happening a lot, right? I'm going to be shaking the camera and other such things. It's plugged in, so I have to watch my power cord, but I can zoom. So, okay, look at that. Wow. Okay. So who cares about the sun, right? It doesn't have any effect. Yikes. I bumped something. Hang on. I know, everything's shaking. I know. Amateur. Yes, that is me. Okay. So who cares about the sun? It doesn't affect your life, right? Well, of course, everyone knows the sun affects your life. Everything happens, right? How many years old you are, that's because since you've been in existence, we've gone around the star that many times, right? If you're 19, we've gone around the star 19 times, right? The star being the sun. So some things you already know. Well, a lot of things you already know. I'm just going to organize some things. So the average distance, right? Almost one, or not quite 1.5 times 10 to the 8th kilometers, 93 million miles, and we learned that's one astronomical unit, right? The average distance from Earth to the sun, right? The diameter, that's how wide is the sun across. If you took 109 Earths and lined them all up, okay, that's the diameter of the sun. Well, that's good news, right? We kind of have a feeling for our own planet. If you look at a map, we know how big California is, we know how long it takes to drive, or it would drive perhaps to LA or something like that, right? So the sun is big, it's really big, but it's not that big, right? It's a finite object, okay? Earth, of course, how long does it take Earth to rotate? Well, it takes one day, right? The sun takes a little over 25 Earth days to rotate at the equator, but it has differential rotation. It takes about 34 days at the poles. The sun is a ball of gas, although it's a very dense, tight ball of gas because gravity is so strong. It rotates faster near the equator and slower at the poles. So that's interesting. That's gonna matter a lot, right? Then composition, right? Mostly hydrogen, helium, then a bunch of other stuff, right? Helium's quite rare on Earth. Helio means the sun, right? Geo means the Earth, like geology, geography, the study of Earth, right? Helio means the sun. Well, helium was an element that they found on the sun. Then they started looking for it for Earth. So that's why it's called helium. It's named after the sun. It's hydrogen. We have a lot of hydrogen. Mainly it's in our water, right? It's combined with oxygen, H2O. It's in our water. So 99.86 of the mass for the entire solar system is the sun. That means if you added up all the planets and the asteroids and comets and all that stuff, it pales in comparison. Most of it is in the sun. It is powered by nuclear fusion. Ooh. We're going to get into that, right? All right, here's some pictures of the sun. Yeah, the sun is active, right? It's really hot. It's got thermonuclear fusion going on in the center. It's really hot, right? And so all that he's trying to get out, but yet there's so much gravity. It's so big, right? What makes gravity is stuff, right? So all that gravity is pulling it in, so it's in a balance. It's in a balance of that, all that heat trying to get out, right? Everyone knows if you know a hot air balloon rises, it expands and rises because the heat expands, right? So all that is trying to expand, but the gravity is pulling it in, and it's at a nice balance now, right? In the early days when it was forming, it wasn't in a balance. It was forming, right? And if life did start on Earth, it could have been wiped out. I mean, who knows? And now the sun is very stable. We're going to learn about that. It's very stable. Well, it allowed life to evolve and to form, you know, and we showed up, right? And life's been happening for, what, about 3.8 billion years or something like that. So, yeah. Alright, we're going to get to this later. We'll skip all this. Okay, let me just skip ahead. Over here. Yeah, is this hokey? Yeah, you bet it's hokey. Okay, sunspots. So, sunspots. You have to know something about sunspots for the test, okay? Sunspots are going to be on a test. So what are sunspots? Are they spots that are on the sun, or are they spots that are caused by the sun somewhere else? Okay, they are spots that are on the sun. They are on the surface of the sun. When we had the eclipse a few years ago, it was a really good sunspot day, and we had telescopes out on top of the science building, and you could see the sunspots. Very, very nice. Sun's been quiet the last few years. There haven't been a lot of sunspots. Okay, dark areas in the photosphere. The photosphere is the part of the sun we see. It's when we look at the sun and never look at the sun, but when you accidentally look at the sun, that's the part you see, kind of like the surface, sort of. It's the part we see, right? Yeah, they form in groups of even numbers. Well, we're going to get into that, right? Sets of magnetic poles. That's a clue. So sunspots, they're dark. Yeah, they're a little bit cooler. The average temperature of the surface of the sun is 5,800 degrees Kelvin. Kelvin, it's different than centigrade. It's like centigrade, except it's 373 degrees less. It starts at zero. There is a zero temperature. So Kelvin is a temperature we're going to use all the time. And it's about 5,800 degrees is the surface of the sun's temperature. So magnetic field. So these sunspots usually last for 2 to 3 solar rotations, which is approximately 2 to 3 months. So let's examine some of the things. It's talking about magnetic field. So we all know Earth has a magnetic field. If we have a compass, right, the needle, this field that's in Earth's, that it's invisible, but we know it has enough energy in it. It'll move a compass needle, right? So and we know that north, right, south. So it moves north, south, and it takes about 80,000 years. Every 80,000 years, give or take, right, thousands of years, it flips. The way they know that is in the middle of the Atlantic Ocean. There's the mid-Atlantic ridge. There's lava coming out. And when the lava comes out, of course, it's molten. It's a liquid. And there's metal in it. Well, the Earth's magnetic field aligns those molecules. Well, the lava goes a ways, and then it hardens because it's in the cold ocean water. And so that keeps happening. Well, then, after 80,000 years, instead of, say, everything being aligned north-south, everything starts being aligned south-north. The lava keeps coming out south-north, then it flips again, right? Well, by the rate of the lava, and if you measure along the ocean bottom, right, the rocks switch polarity. They estimate it's about every 80,000 years that Earth's magnetic field switches. So the sun switches, what do you think? 80 million years, 80,000 years just like Earth? It's about 11 years. Really quick, right? Really, really fast. I'm just going to look at the camera here because this is amateur hour. Hang on. I don't think you can see me at all when I'm talking. So let me back off a bit. We'll try and get a happy medium here. It'll get better, folks. Maybe it won't. Maybe the production will never get better. We'll see. Okay, so sunspots are governed by the sun's magnetic field. The Earth has a magnetic field. Earth, though, the magnetic field goes through the center, right? It goes up through the center and then spreads out like that, right? If you have Earth, the magnetic fields come up through the center. On the sun, it's different. In the center, there's thermonuclear fusion. On the sun, the magnetic field is at the surface. It's so hot that electrons get stripped off of elements and molecules, So electrons are negative. When they leave a substance, that's now positive. Well, you have negative and positive charges, that's electricity. When you have electricity flowing, you have a magnetic field. That's the way it works. So you have this magnetic field at the sun's surface. But remember, the sun, it rotates differentially. The center rotates quicker. Ooh, drama. So how does that affect things? Well, I'll show you that in a second. First, let's take a look at the sun, some sunspots. They're about the size of the Earth, right, a sunspot. Dark part in the middle is called the umbra, the penumbra, right? But they're about the size of the Earth, these spots that are on the sun, and they come in pairs, right? Here's another one. Here's a nice picture showing the sunspots. Okay, so what is a sunspot? So you have this magnetic field at the surface. Well, sometimes they break the surface, right? The sun is a ball of gas, so it's not like Earth where you have a solid surface. There's an ocean, but beneath that it's solid. So the sun is gas, right? So you have this magnetic field flowing, so the surface is kind of a nebulous area, right? It's not so defined. It's defined, but not like on Earth. So they break the field, but right at that point, it'll be a little bit cooler. That's why you have the darker spots. So I forget the temperature, 4,000 degrees. If the surface is 5,800 degrees, it's still, the sunspots are still hot, but they're cooler, right? So what'll happen, notice this picture here. You'll have the ones in the northern hemisphere of the sun going south to north, but in the southern hemisphere, they're going north-south, north-south. They come in pairs. After 11 years, it flips. Then the north would be north-south, north-south, and the south will be south-north, south-north. Then approximately 11 years. This is between 8 and 13 years. It flips, right? Interesting. So you got to know that. You got to know the cycle, right? That's a test question. It's about 11 years on average for the magnetic field to flip. 22 years it goes back, right? Test question alert, right? They come in pairs. Yeah, well you can remember that because a magnet always has a north and south. If you buy a magnet, it has a north pole and a south pole, right? Buy a little bar magnet. If you cut a magnet in half, there's no such thing as just a north and a south. Now the internet says that there is. The internet crackpot says that there is a north and a south. There isn't, right? If you cut a magnet in half, well then that piece will have a north and a south, right? All the pieces will have a north and a south, right? Yeah, don't listen to the internet, right? We're learning critical thinking here, right? We learned logical fallacies, right? So, okay, so this is a really good diagram. I'm going to check the camera again because we're going to make it hokey and amateur. All right, stand by. Maybe you can see me. Maybe the top of my head is cut off. I want to make sure you can see the screen pretty well. Let me zoom in on the screen more. That's more important. I was just showing sunspot pictures before. All right. Okay. Let me go to the previous image just to make sure you saw that. Let me go just to make sure you saw that. You may not have been able to see that. Yeah, so you saw this, what sunspots look like. Then this image here. Here the sunspots come in pairs. This says south, that says north. This says south, that says north. And in the southern hemisphere, it says north, south, north, south. So that's an N and an S, an N and an S. And then this is showing where the magnetic field has reached the surface and it's going from south to north. In the southern hemisphere, they're going from north to south. And here's a depiction of, this is a picture of, in the ultraviolet, this is a picture of the magnetic field flowing out of the sun's surface, photosphere, okay? So that's that again. Now this is a picture showing the differential rotation. Let me make sure you can see this. Okay, yeah, you can see that pretty good. I hope. Oh my God, let me zoom in on that a little bit more. It's more important that you see this than see me. Way more important. Okay. So here's what I was talking about, right? So the sun spins counterclockwise, right? Interesting. Remember that when we talked about the way the stars seem to move in the sky, it was counterclockwise as well, huh? We'll get into that later, but interesting, a clue, right? So you have the sun's north pole, right? Remember, at the equator, it spins faster. So that magnetic field gets all wrapped around. It gets really complicated. It's not like Earth. Earth, the magnetic field just kind of comes up through the center, right, and goes, and it's nice. No, the sun, it's all wrapped around, and it's quite complex, right? That's why studying the sun is very complex, right? Heliophysics is solar physics. It's a whole field unto itself. So the magnetic fields get quite distorted because of a differential rotation, meaning that at the north and south it rotates slower, right? It goes quicker. So the magnetic field gets all wrapped around, right? And then occasionally the fields will breach the surface, right? And that's where you have sunspots. And usually the way it works is that during the 11-year cycle, the sun will have a quiet time, and it'll also have a more active period. And that can affect things. When the sun's more active, it can affect our communications on Earth and that sort of thing. In theory, if you had some huge solar flare that was aimed right at Earth, it could cause mass extinctions and stuff. So there have been many mass extinctions if you go through the geological record. So yeah, does the sun cause them? Sure, it's as good as any reason why we've had the extinctions. They can check, the geologists and paleontologists look at all the different layers in the geological record, and yeah, you got all this life all of a sudden gone, and some new life kind of takes over, or life that wasn't so popular, now it's the main thing, right? It happens all the time. So not a question of if, just a question of when, right? So okay, so that is that, right? The magnetic field is responsible. Test question: the magnetic field is responsible for sunspots, okay? This is just kind of showing the magnetic field coming out, right? Now, so it's about an 11-year cycle. They've been studying the sun for a long time. The Chinese have written records where they've talked about it from 1,000 years ago. We think they looked at it, at sunset. Galileo was the first person to look at sunspots through a telescope. Don't ever do that. Galileo was blind, right? They say he was blind. You don't look at the sun with a telescope. Right? They soon figured out after Galileo that you could just project that image onto a piece of paper or parchment was what they had back then, and you could see the sunspots without looking through the naked eye. And that's the method they use, right? They learned that early on. Never look at the sun, right? Unless you have special filters, and But yeah, so here's just some data going back to 1900, and it shows sunspots, right? And when they first start off, right, if you have the equator, right, so the way latitude works, it starts at the equator at 0, and then it goes 10, 20, 30, right, 90 degrees at the North Pole. Pittsburgh is at 38 degrees. So if you're at the equator, like where Ecuador is, if you go up 38 degrees, that's where Pittsburgh, California is, right? If you go all the way up to the North Pole, that's 90 degrees latitude, right? So on the sun, if you go up to about 30, 40 degrees, the sunspots in a new cycle, they start way up there. Then as the 11-year cycle goes, it gradually gets closer to the equator, and then just as that cycle is ending, another cycle starts, and there's a little bit of overlap. That's called Sporer's law, after the person named Sporer, who documented all that, who discovered that. It is a 22-year cycle because it's an 11-year cycle. It switches, and then after 22 years, it goes back where it was. So. And there's just some interesting data. between 1645 and 1715, it was a real quiet period where there were few, if any, sunspots. So the sun's been quiet the last few years. It's been unusually quiet. So that we don't know why. Of course, we've only been monitoring the sun as humans for 1,000 years, taking data since just after the 1600s. So, you know, who knows what the sun really does, right? We've only been looking at it for a short time, relatively speaking, right? Long for us, but we don't live long. Okay. Sunspots. How about that?